Okay, in today's video we're making here in class, we're going to be learning all the ways that we can write an absolute value equation as a piecewise equation. Okay, so just as a refresher, all absolute values graph to some sort of a V. Right, that's a two-piece. So we're going to split this into two types of linear equations. Right, we're going to do that based upon its vertex, or potentially vertices. So we're going to write an equation for the left side, right? This is a linear equation, some sort of y equals mx plus b equation, right? For the left side of that graph, as well as for the right side. This is another y equals mx plus b equation. Now, usually, not always, but usually, this is going to have a negative slope, right? Because the slope is going down and to the right. So your leftmost equation will be negative sometimes, and I guess it can be positive. It doesn't have to be negative, but if the graph ever goes down, right, from left to right, then you have a negative type of a slope, and the right side is probably going to be a positive type of a slope. Okay, so we're going to end up writing this as two equations. Okay, some type of a mx plus b equation for your linear. If x is on the left side, right over here, the left side of this line, whatever that happens to be, and then you have your other type of an equation if x is on the right side of your fence. Okay, so this is what we're looking for. We're looking for some equations with some constraints. That's what our final answer is going to be looking like. Okay, so let's look at our examples and see if we can do that kind of stuff. So here's our first one. We're given the equation absolute value 2x plus 4 minus 3. Okay, and we're asked to do a little sketch here of it. Sketch the graph using strategies learned in Algebra 2, aka finding the vertex and using the slope. Okay, so we did that by figuring out what makes this 0. So we're going to find the vertex. So what makes 2x plus 4 equal to 0? Okay, and hopefully you know when we subtract 4 from both sides and divide by 2, we get an x value of negative 2. Okay, so that's the x coordinate of your vertex, and then based upon our transformations, that minus 3 is going to move your graph down 3 units. So our absolute value is going to have a vertex at negative 2, negative 3. Okay, so we'll plot that here, negative 2, negative 3. And then we can use the fact that it has a positive 2 slope. So this is Algebra 2 stuff, a positive 2 slope. And it's a positive v, so our v should look like the normal v. So on the left side of our vertex here, we're going to go up 2 and left 1, because this is a negative 2 slope, making our v that goes to the upper left. Okay, so there's your v to the upper left. And then we're going to go up 2 and right 1, using the positive 2 slope to the right. Okay, now this isn't the best looking v, but that would be our v. Okay, so some things to know about the v, right? We have the gap down the middle, or rather the axis of symmetry right down the middle. So we're looking at the left side of negative 2, and we're looking at the right side of negative 2. So now let's write the equation of our line. Okay, so the left side here has a negative 2 slope, right? It's down 2 and right 1. So we write that as a negative 2x, right? Negative 2x. And then if we were to continue, right, using our slope, we would see that it would cross your y-axis at negative 7. So our left equation would be negative 2x minus 7. Now the right equation has a positive 2 slope, 2 up, 1 over, and a y-intercept of positive 1, right? We can actually see it this case because it crosses the y-axis. So this would have a 2x plus 1 equation. Okay, so that's how we did this thing in Algebra 2. We used the vertex, we plotted it, we used the slopes and approximated the intercepts, and then you wrote your equations. So now let's get into the pre-calculus procedure. So here are the procedures right here, 1, 2, 3, and 4. We'll get to them in a second. But it starts with setting the expression inside of the absolute value equal to 0. Okay, so we notice that 2x plus 4, that is the stuff inside of the absolute value. So that is what we set equal to 0. Okay, just like we did up above to find the vertex, right? We set it equal to 0, and we found that x is negative 2. Okay, so this is basically your constraint. It's going to become your constraint here in a second. Okay, so now that we have solved this, and if there were multiple absolute value bars, we would solve each of them individually, which is going to come up in our next example. But now we draw a number line and divide it into intervals using the values that we just found. So we draw a number line and we put negative 2 in there, right? And then we're separating this into the left side of negative 2 and the right side of negative 2. Okay, so this is our important point. This is our constraint. Right, just like you saw in our previous graph, that was your axis of symmetry, what separated the left side from the right side. And we're going to, it says, write the entire equation of the function in each interval, replacing the absolute value bars with parentheses, right? This is the procedure. So we're going to come in and we're going to write parentheses 2x plus 4 minus 3. And we're going to come over here and write parentheses 2x plus 4 minus 3. Okay, so this is the procedure. Right? We're not going to do anything with this just yet. We're setting it up so that we can do something with it in a minute. Okay, so then the next step is what we're going to do. We're going to determine the sign, whether it's a positive or a negative. Okay, we're going to determine whether we have a plus or a minus in front of each of these equations. So is that going to be a positive value or a negative value? And we do that by choosing an x value in the interval. So pick a number less than negative 2. Negative 3 is definitely a number less than negative 2. Okay, in addition, pick a number that's greater than negative 2. Negative 1, or I'm going to pick 0. I love doing math with 0, but negative 1 would work as well. Positive 1 would work, right? 92 would also work. Any number greater than negative 2 will work. Okay, and what we're going to do is we're going to replace x just in your parenthesis. Right? We're going to plug x into here only. We're not going to worry about that minus 3. You're only going to plug it into 2x plus 4. Okay, so what is 2 times negative 3 plus 4? Okay, that's negative 6 plus 4. It turns out that that value is negative 2. Okay, so the fact that we have a negative 2 means a negative is going to go out here in front of your parenthesis for your equation, right? This is going to become, this right here, this is going to become your linear equation, right? We're going to simplify this down, and we're going to have a negative in front there, okay? So we're setting up the sign. Now let's do the same thing over here. What's 2 times 0 plus 4? Right, so that's 0 plus 4 is a 4. Now, the fact that it's 4 is okay, but we know that it's going to be a positive, right? We have a positive number, so that's going to be a positive value. That's going to go into there. Okay, so that's what step number 3 says, is determine the sign of your parentheses. Is it a positive sign or is it a negative sign? Okay, and then place that sign in front of each expression. And then the last thing is to simplify. So let's simplify this down. Okay, so we're going to distribute in the negative. Negative 2x minus 4 minus 3 gives me a negative 2x minus 7 equation. Okay, and likewise, Over here, there's nothing to distribute, so just 2x plus 4 minus 3 comes out to be 2x plus 1 as my linear equation. Right? The whole point of this is to be able to write linear equations. So there's your mx plus b, like we were expecting to have for all of these absolute values. Okay, and then the last thing, write it as a piecewise. Okay, so we have your brackets here, right? We have our function equals, and we have to decide which one of these equations goes on top and what equation goes on bottom. And then what are your constraints? Well, pretty much always the less than or the left equation, and this is on the left, right? That is literally on the left of our negative 2. That's going to come first. So negative 2x minus 7 is going to be the one on top because that's the equation to the left of negative 2. And less than means left. So we use the less than or equal to. And then our other one, right, this equation will be on the right side because it's literally on the right side of negative 2. The way that we drew it was purposeful. And the right side is greater than. And they can both be or equal to. It's okay since this is a continuous function. There's not going to be point discontinuity. There's not going to be jump discontinuity. It's going to be continuous the whole time. Okay, so notice that the equations that we algebraically came up with were the same ones that we graphically came up with. Okay, and that better happen because it's the same absolute value equation. Okay, now that's an intro. So let's flip this worksheet over so we can look at some more examples. So here we have an equation that has, in this case now, two absolute values, an x plus 2 and a 2x minus 3. So we're going to write that as a piecewise defined function. Remember, so we're trying to figure out what linear equations these are going to be written as. So step number 1. Take your absolute value thing and set it equal to 0. Okay? X plus 2 equals 0. Take your other absolute value thing. Everything that's in an absolute value, you do this with. So we have two absolute values, so we find two solutions. Okay, so the blue one, x equals negative 2, and we subtract 2 to that side. And for the red one, we're going to add 3 and then divide by 2, and we get 3 halves, or if you're so inclined, 1.5. Since this is a nice decimal, we could write that as a decimal. Okay, so there's step number 1. Set each of your absolute value stuff, and only the absolute value stuff equal to 0 and solve. Now that breaks our number line into 3 different intervals. Okay, there's the interval to the left of negative 2. There's the interval in between negative 2 and 1.5. And then there's the interval to the right of 1.5. So we should be expecting 3 equations. One from the left of negative 2, one from the middle, and one from the right. Okay, so procedurally, the next thing we do is we write down our absolute value equations with parentheses. Okay, so we leave a little space in between here so that we can put our sign. We can put our sign whether it's positive or negative. Remember, the sign comes from choosing a value over here. So maybe we'll pick negative 3 to try. And then in between, let's pick 0. I love doing math with 0. And then maybe to the right, we'll pick positive 2. Okay, so we're picking of x value in that interval. Okay, to the left of negative 2, in between negative 2 and 1.5, and then to the right of 1.5. And what we're going to do is we're going to plug it into your equation. So we're going to do negative 3 plus 2, right? And we're going to evaluate, is that positive or negative? Well, we get a negative 1, so that means we're going to have a negative sign in front of that parenthesis. And we do the same thing with our next. What is 2 times negative 3 minus 3? Okay, negative 6 minus 3 is Negative 9. So this parenthesis also gets a negative. Okay, and in a second, we're gonna actually simplify all of this together to get one linear equation. Okay, so for the middle, what is 0 plus 2? It's a positive, so you don't have to put a plus, right? You can leave it blank because positive and blank are the same things. But what's 2 times 0 minus 3? Is negative 3, so we have a negative in front of that parenthesis. Okay, we're going to evaluate that one also. Okay, the third one, what is 2 plus 2? Right, 4. So this is going to be a positive in front of that parenthesis. And then 2 times 2 minus 3 is a positive also, so we're going to have a plus in between there. Okay, so now we're going to come back and we're going to simplify all of these. We're going to distribute those negatives and the positives. We're going to combine like terms until we get 3 equations that are all linear in nature. So there are your 3 equations. Now we're going to take these equations and we're going to write them as a piecewise function, right? So here is your brackets. Okay, the left equation was the one in blue, negative 3x plus 1. Okay, and then your middle one was the middle, negative x plus 5. And then the right one is the bottom, so that would be a 3x minus 1. Those are your 3 linear equations that we came up with when we distributed those negatives and we combined like terms. Okay, now what about your constraint? So this is x is less than negative 2. Right, your next one is between negative 2 and 1.5. Right, just like we had on the chart. And then this one is greater than 1.5. Okay, so remember, these numbers are coming from your things that we solved a minute ago. Right, we solved them over here. Those are your constraints. So we have negative 2 as a constraint, and we have 1.5. So to the left of that, to the middle of that, and then to the right. So now, how are we going to graph this little puppy? Let's talk about graphing it. We know that the fence is at negative 2, right? So we can put a vertically dashed line here through negative 2. This is going to be one of our places where the graph changes. And then the other one is going to be at 1.5. So let's see if we can get 1.5 right through the middle of 1 and 2 to the best of our ability. Like that. So there's a couple ways we can graph it. We have negative 3 plus 1. So that would cross the y-axis at positive 1, right? But we're not going to actually graph it in here because we can only graph it to the left of our blue line. So we can imagine that it crosses here and using a negative 3 slope goes up 3 units and 1 to the left. Okay, up 3 units and 1 to the left means it's going to cross my y equals negative 2 line at positive 7. Okay, a closed dot right there at positive 7. Or we could have plugged a negative 2 into x and also gotten positive 7 as the y value when x is negative 2. Okay, so there's a couple of ways that we can figure out what that point is. Now the rest of it is the slope. So we're still going to go up 3 units and left 1 because it has a negative 3 slope. So up and left is a negative direction algebraically. So we can do the same thing with negative x plus 5. What if we plug negative 2 in for x? The negative of negative 2 is positive 2, plus 5 is 7. So our middle graph is starting here at 7. Right? So it's continuous, and it has a negative 1 slope. So down 1, right 1, down 1, right 1, down 1, right 1. And then we're going to run into our fence somewhere there at the half. Right? So it's not going to be at a whole value. It's going to be somewhere at a half. So let's do a similar thing with our last one. We can plug 1.5 in here, right? 3 times 1.5 is 4.5. 4.5 minus 1 is 3.5. Okay, so once again, it starts here where the red one ended. But then how about the slope, right? How do we count 3 from there, right? We don't. You can only count 3 from an actual point. So let's see. what's going on when x is 2? There's another point. What about when x is 2? 3 times 2 minus 1 is 6 minus 1, which is 5. So there's a whole number point at 2 comma 5. Okay, now once I have that whole comma point, I can figure out the slope by counting rise over run until I run out of graph. Okay, so we can plot the first y point on that fence by plugging 1.5 into your equation. But then from there, you have to figure out where an intersection point is so we can use the slope. Okay, so you go to the next whole number x value and you plug that into there so you can get your graph. Okay, so we have 3 different linear equations that make up this double absolute value piecewise function. So our last example here. Now we have a fraction. So what we always have to remember about fractions is we need to restrict our domain. The denominator can't be equal to 0. So no matter what is going on in our fences or anything other constraints, we know that x cannot be negative 3. Okay, if x is negative 3, then it will make this an asymptote and undefined, and we can't have that happening. Okay, so back to our strategy. Number 1 is set your absolute value equal to 0. So x equals 5. So we put 5 on our number line, right? And that becomes your constraint. So we have everything to the left and everything to the right. So we write our equation, right, with parentheses. Parentheses 5 minus x minus 8 over x plus 3. Okay, 5 minus x minus 8 over x plus 3. And we're trying to figure out whether there's a plus or a minus in front of your parenthesis. Okay, and to do that, we pick a value to the left of 5, and we pick a value to the right of 5. Okay, and you only go into your parentheses. You go into your parentheses. So what is 5 minus 0? Of 5. So we know that this is a positive value on that side, so we don't have to really worry about doing anything. And what is 5 minus 6? Negative 1. So we know that there has to be a negative in front of that parenthesis. Okay, so now maybe the hard part is simplifying each of these down to their fractional equations, right? So you're going to get a fraction for both of these. So when we simplify the left side, we notice that we can factor out a negative from both of these, and that helps us by canceling out the numerator and the denominator. So the left of positive 5, my answer is just negative 1. And to the right of positive 5, my answer is this fraction, which is okay. A fraction is a rational, and that's fine to have. So we can write our piecewise function. Y value is always negative 1 if x is less than positive 5. But of course, not equal to negative 3, right? That was our constraint for your denominator. That was your restriction. X cannot be negative 3. And then to the right of positive 5, we get this x minus 13 over x plus 3 business to the right of positive 5. Okay, and that's where our last thing says, what do we have to take into consideration? We have to take into consideration the denominator, right? The denominator cannot be equal to 0. So anytime we have an x with a 0 in the denominator, we have to have one extra thought in our brain about the constraint, or about the thing that has to make the denominator 0 has to be not included in your answer. Okay? So there you go. Hopefully that's a little better at writing equations, linear equations from absolute values.